Guys, something impossible just happened. 5 years ago, astronomers watched a mysterious interstellar object named 3IATLAS drift past our solar system. It broke apart, faded, and disappeared into the dark, gone forever. But now, telescopes across the world are detecting something strange. A signal. Not just background noise, but a repeating, rhythmic pulse, coming from the exact coordinates where 3IATLAS once was. It shouldn't exist. There's no active source out there. No known comet, no asteroid, no satellite. And yet, the universe just blinked back at us. According to the SETI Institute, the first signal appeared on October 12, 2025, picked up by the Allen Telescope Array in California. A clean burst at 1420 megahertz, the hydrogen line, often called the frequency of life. And here's the part that's truly mind-bending. That exact same frequency has been used for decades by scientists, searching for extraterrestrial intelligence. So, what are the chances that a long-dead interstellar object just started talking in the one frequency we listen to the most? At first, astronomers thought it was a glitch, a technical echo from a satellite. But within hours, 3 different observatories detected the same pulse, each lasting 4.3 seconds, separated by exactly 22 minutes. That pattern was too precise to be random noise. And when data came in from the Gaia Space Observatory, things got even weirder. Gaia recorded a faint shimmer of light at the same coordinates, a flicker that matched the radio, burst timing almost perfectly. It was like the light itself was pulsing in rhythm. Dr. Elena Ruiz from ESA put it simply. It wasn't just a signal. It was synchronization, something that seemed aware of its own timing. The data lined up perfectly with the last known rotation. Model of 3IATLAS, a spin every 22 minutes. Coincidence? Or was something out there repeating the comet's long-lost heartbeat? Here's where it gets seriously strange. The signal's pattern wasn't random static. It showed decay and recovery, almost like respiration. Imagine a broken satellite still trying to reboot over and over again. Only this time it was an object billions of kilometers away, and supposedly dead. The signal intensity rose every time Earth rotated toward that region of the sky, then faded again. It was almost as if something out there was aware of our observation window. Astrophysicist Dr. Raven Chen described it best. If 3IATLAS truly disintegrated, something else is sitting in its place, and it remembers how it used to move. Think of it like this. A shipwreck at the bottom of the ocean, still sending out sonar pings long after it sank. Within days, a global effort began. NASA, ESA, and SETI formed a joint signal analysis task force. Their goal? To triangulate the origin and verify the source's reality. Since that moment, everything changed. Global observatories redirected their antennas toward interstellar space. The Very Large Array, FAST in China, Meerkat in South Africa, all began rescanning the region where Atlas once passed. SETI's funding doubled overnight. Private telescope networks like Skylark, Las Cumbres, and Astronet began combing through petabytes of archived data, searching for even the faintest trace of repeating hydrogen drift near the heliopause. And here's where it gets fascinating. This event didn't just change astronomy. It changed philosophy. For decades, communication meant words, syntax, intelligence. But now scientists began to ask, what if communication is bigger than language? What if it's written into physics itself? Maybe this wasn't a message from a civilization. Maybe it was the universe itself resonating, a form of self-expression in the language of energy. That's when theoretical physicists entered the conversation. Some suggested it might be stimulated emission feedback, a natural process where hydrogen fields echo back radio waves across magnetic boundaries. Others proposed something stranger, a cosmic neural feedback, where charged plasma behaves like memory, briefly recording and returning what it receives. It sounds insane. But so did radio waves once. Here's what fascinates me. Even if it wasn't intelligent, it felt intentional. The timing, the reflection, the silence before and after, it all carried a rhythm. It reminded us of something ancient, the heartbeat of a living world. Only this one beats across light years. And maybe that's the point. Maybe intelligence isn't the signal. Maybe structure is even broken systems, fragments, echoes, fading comets, can still speak in the only language the cosmos truly understands, rhythm. The hydrogen line itself, 1420, 405 MHz, that's not just a frequency, it's the most fundamental wavelength in existence. It's the signature of hydrogen, the first element ever created, the building block of everything. Stars, galaxies, humans. It's a note every atom can sing. Every cloud, every sunbeam, every particle in your body, all tuned to the same cosmic pitch. So when 3IATLAS echoed that hydrogen pattern, it wasn't random noise. It was like the universe humming to itself. And for once, we were listening. Maybe the universe isn't quiet. Maybe we just weren't hearing it right. Until now. So what's next? Right now, astronomers are still analyzing the repeating bursts. The James Webb Space Telescope has focused its instruments on the trajectory region, the Gaia DR4. Data release is being cross-referenced to look for gravitational traces, any sign of a physical remnant, a dust plume, or even a plasma wake. Early readings hint at something faint. 3 observatories, Parkes in Australia, Meerkat in South Africa, and Jodrell Bank in the UK, all detected the same burst within a 3-second margin. That means the source is real, and it's coming from about 2.4 astronomical units beyond. Mars drifting toward the heliopause, the outer edge of our solar system. At that distance, 3I-Atlas's fragments should be frozen, inactive, silent. Yet something was generating structured radio energy. As one researcher put it, it's like the universe hit play on an object we thought was gone. And here's where emotion meets science. Excitement clashed with fear. Because if a broken comet can send a rhythmic hydrogen signal, then we may have underestimated what interstellar debris can actually do. Scientists rushed to explain it, but their theories couldn't agree. Theory 1, it's natural. Ionized debris is interacting with solar magnetic fields, producing periodic resonance. But that doesn't explain why it's so precise or so repetitive. Theory 2, it's artificial. Fragments acting like a massive reflector, unintentionally bouncing radio waves in a repeating loop. But that would fade quickly. This didn't. Theory 3, there's something else out there, possibly another interstellar object passing through the same trajectory, triggering electromagnetic echoes. To make things more confusing, the signal sits right on the 1420 MHz hydrogen line, the same range where the famous "wow" signal was detected in 1977. Dr. Luis Ortega commented, "It's the exact kind of transmission SETI looks for. Narrow band, structured and coming from nowhere near Earth." But when the signal's timing shifted slightly, exactly when Earth rotated away, everyone's theories broke apart. That moment became the turning point. This is when scientists started questioning everything. Audience checkpoint. What do you think is happening here? Drop your theory below, because this next part changes everything. A few nights later, new detections came in. This time, the signal jumped to 1666 MHz, a frequency rarely used in astronomy. At first, it looked random, until pattern analysis revealed amplitude modulation, as if the signal's volume was changing deliberately. Even more bizarre, the European Deep Space Radar detected faint ionized arcs around the same region, forming symmetrical shapes, not chaotic like normal plasma noise. It was as if something out there was creating interference on purpose. Researchers compared it to binary code, ones and zeros, but stretched across cosmic distances. The data visualization looked like a heartbeat morphing into language. And one physicist whispered during a press call, "If this is natural, then nature just learned to communicate." SETI did something unprecedented. They decided to answer back. Using the Allen Telescope Array in Northern California, a small team of radio astronomers did something bold. They sent a return ping and a precise, narrowband hydrogen echo beamed along the same line where the 3I-Atlas signal was first detected. It wasn't a message. No greeting, no words. Just a clean scientific response. A 4.3-second hydrogen pattern, perfectly mirroring the original anomaly detected weeks earlier. Then silence. An empty, weightless kind of silence that fills entire nights. For 72 hours, nothing happened. No spikes, no repeats. No interference. The screens in the control room stayed flat. You could feel the disappointment thick in the air. Some scientists tried to rationalize it. Maybe the original signal was a reflection off space debris. Maybe it was cosmic noise, a coincidence, or even a calibration glitch. But the data team refused to pack up. They kept listening, rotating the dish in micro-adjustments hour after hour, tracing the faint path near the heliopause, the outer edge of our solar system. And then, on the 4th day, a faint ripple appeared. At first, it looked like interference from a passing satellite, but when they matched the pattern, every jaw in the room froze. It wasn't random. It was the same 4.3-second sequence, only inverted, a perfect mirror of the reply they had sent. Not a voice, not a language, just a reflection, as if the universe itself had blinked back. A cosmic acknowledgement, as if something or someone had simply said, "I heard you." Within hours, the story spread beyond the observatory. By morning, it had escaped into the world. Headlines flashed. Earth just got a reply. SETI detects mirrored hydrogen echo. The universe may have answered back. The clip of the static replay hit Reddit, then TikTok, then news outlets. Millions of people watched a simple waveform, white noise on a black screen, and tried to find meaning in it. Some heard rhythm, others swore they heard a pulse. But most were just stunned by the possibility. For decades, we've been asking if we're alone, and for the first time, it felt like something answered. On Reddit, a user named Deep Field Echo wrote a comment that went viral. "It's not talking to us. It's just letting us know it's still here." That single line, poetic, eerie, haunting, became the unofficial slogan of the event. People printed it on shirts. Astronomy blogs used it as headlines. It echoed through every corner of the internet. Because that idea, that something might be out there listening, captured the global imagination overnight. News anchors stumbled to explain the science. Talk shows debated if it was alien. Politicians tweeted, "Maybe we're not alone." But to the scientists who started it all, the real story was quieter, more profound. This wasn't just a mystery. It was a mirror. Even now, scientists keep their antennas pointed at the stars. They know it might be years before another echo returns, or maybe centuries. But the excitement hasn't faded. Every night, data streams down from arrays across the world. Terabytes of noise, static, background hum, and buried inside, maybe another heartbeat. Another 4.3-second whisper from the edge of everything. And it makes you wonder, was this just an echo? Or the beginning of something entirely new? What if the universe isn't sending us messages in words, but in timing, in symmetry, in resonance? A cosmic Morse code that doesn't say hello, it just says, "I exist." So next time you look up at the night sky, remember this: somewhere beyond the solar wind, a faint hydrogen pulse still drifts through the dark, a ripple that began with a dying comet and ended with us listening. Maybe we didn't find aliens. Maybe we found awareness. And maybe, just maybe, the universe has been whispering all along. We just finally heard it. Soft static fades out, replaced by gentle piano. Subscribe next week. We'll explore the mysterious mirror signals near Jupiter's orbit and what they could mean for our understanding of interstellar communication.